Welcome to YCAD Wonders. This is Ganesh from Bangalore. Actually, initially I thought of taking up fractions in this session. Okay, but later I decided to have additional session by name Vantage Point to act as a knowledge booster. Okay, on the recent topics that were covered, you may consider this session to provide some summary or tips or hints or shortcuts or tricks, or you can take it as a session for more practice or for gaining more confidence. Okay, so far recently we have discussed the topics on integers, prime numbers, okay, factors, multiples, and so on. Factors, multiples, HCF, LCM. Okay, let's see some more on this. Okay, there is a difference. There's a term called difference. Sum of two numbers means you will add, correct? Sum of say sum of 3 and 7, okay, is 10. Similarly, sum of 7 and 3 also 10. Okay, what about difference? What is difference between difference of 7 and 3? Okay, then so it is 7 minus 3, 4. But if I ask what's the difference between 3 and 7, then here confusion comes. Say some way say 3 minus 7, which is equal to minus 4, or some may say difference is 7 minus 3, 4. So okay, which is correct? Okay, you should know difference of any two numbers is always positive. So that means what? So how do you get a positive number? Difference always positive means what? So to find a difference, should always subtract smaller number from bigger number. Okay, so remember this. So difference is equal to bigger number minus smaller number. So then only we'll get the positive number always. So here what is bigger number? Bigger number out of 3 and 7 is 7. So 7 minus 3, 4. Okay, whether the difference between 7 and 3 or 3 and 7, okay, it is 4. Difference is always positive. Okay, I want to make it clear to you. And also the difference between the terms and, for example, so between 7 and 3 or 3 and 7, and between, okay, let's take the other way. So between 3 and 7, another one is from 3 to 7. Okay, if it's between, then you should not take the border values. So 3 and 7 should not be included. So suppose how many numbers are there between 3 and 7? So 4, 5, 6, only 3 numbers, correct? 3, sorry, 4, 5, 6, 3 numbers. So from, so how many numbers are there? By number I mean the integers are natural numbers, that's what I mean, are whole numbers. So how many numbers are there from 3 to 7? So then 3, 4, 5, 6, 7. So there are 5 numbers. Okay, now what's the how many suppose so how many numbers are there between let's say 17 and 71? So how will you find? So will you write all the numbers and count? No, it's not required. So what to do? You subtract. So is it the answer? Is the answer 71 minus 17? So what do you get? 17 minus 17. So 4, 5, 54. Is it correct? So 54 numbers between 17 and 71. No. So before you come to that conclusion, you any okay. So want to find any solution to any problem. So if you are not sure, you take a small set of numbers, simple numbers, and see how to approach that problem, how to get the solution. Then you can apply the same logic. See, for example, suppose you want to find the numbers, how many are there between 3 and 7. So what is that? Suppose you subtract 3 from 7. So say 7 minus 3 is what? 4. So we get 4. Is it 4 here? See, but you see it's not 4, only 3 numbers between 3 and 7. So what we should do? So you find the difference and subtract 1. See, 54 minus 1, 53 numbers, not 54. Okay. Similarly, suppose the question is how many numbers are there from 17 to 71. Then in that case, again same, find the difference. So 54. Okay. So find the difference. 71 minus 17, you get 54. So in this case you add 1. So 55. Okay. So there are 55 numbers from 17 to 71 and 53 numbers between 71, okay, and between 17 and 71. And see the factors, when we discussed factors, I told you how we can find all the fractions without missing any factor. So for that what we did, for example, want to find the factors of 24. So we did like this: 1 into 24, 2 into 12, 3 into 8, 4 into 6, it's not divisible by 5. Okay. So that's then 6 into 4 next. So again same thing. So 4 into 6 or 6 into 4. So then we wrote like this. We write all the factors here. 1. Say factors of 24 are 1, 2, 3, 4, 6, 8, 12, 24. Correct. So if it is say prime, say how many, you will always get a even number of factors if it's not a square number. Okay, square number meaning, okay, let's say for example 25 is a square number because that can be written as 5 into 5 or 5 square. Okay, if it's a square number, then you will get odd number of factors. Say for example 20 factors of 25, so you can write 1 into 25, 2 is not divisible by 2, 3, 4, so it's 5 into 5, that's all. So factors are 1, 5, 25, 3 factors. Okay, same way, suppose we want to check whether the given number is a prime number or not. See, in a prime number means what? Okay, it's divisible. It has exactly two factors. Divisible by 1 and the number itself. Okay, it should not have more than two factors. So how to check whether number is prime or not? So I want to check whether say 37 is prime or not. So do we have to divide that by all the numbers from 1 to 37? No, not required. So same concept you can apply here. So here what do you get? See, take two numbers which is a product of which is close to 37. For example, see 5 into 6 is 30, correct? 6 into 7, 42. So that's so 6 into 7 will gives a number which is more than the number 37, which we want to check whether it's a prime or not, correct? So this is the what is the bigger number here, 7. So you just find all the prime numbers okay, less than or equal to 7. So what are the prime numbers less than or equal to 7? 1 is not prime, 2, 3, 5, 7. So it's enough if you check whether it's divisible by any of these numbers, 4 numbers. Okay, if it's not divisible, then we can definitely say it's not a prime. Say 37 is not divisible by 2, it's not divisible by 3 because sum is not divisible by 3, and 5 is not divisible by 5, it's not divisible by 7 also, correct? So therefore we can say 37 is a prime number. So you need not divide by any other number more than 7, like 8, 9, 10, and you need not divide. Okay, so this way you can easily find whether the given number is a prime or not. Okay, this is about prime numbers. Okay, then okay, let's discuss more on HCF and LCM. Okay, suppose we want to find the HCF and LCM of these numbers. Okay, let's say 16, 24, 48. Because suppose I want to find this using common division method. So general rule is to divide this by prime numbers. And again you can divide by any order, it doesn't matter whether, say for example this one is divisible by 2, correct? So 2. So suppose divisible, all of them are divisible by 3, then you can divide both 3 and 2 and 3. You can, it's your choice, you can either first divide by 2 or divide by 3, doesn't matter in which order you divide. Suppose you divide by 2, then 8, 12, 24, then again 2, 4, 6, 12, 2 again, 2, 3, 6. Okay, now again 2, 1, 3, 3, now 3, 1, 1, 1. Okay, so you can divide like this, or see, suppose you can even use do this way. Suppose you divide by 2 first here, so you get 8, 12, 24. Suppose instead of dividing by 2 we want to divide by 3, it's fine. So divide by 3, then 8, 4, 8. So now we can divide by 2, 2 again, and 2. Okay, another thing I think as I said earlier, suppose okay, all the given numbers are divisible by say composite number. You can divide by the composite number also. You need not divide by prime number. Okay, but only few of the numbers are divisible by composite number. Then you should not. You should use only prime numbers. Okay. See, for example, so same thing, same. Okay, then okay, from this what I'll come to later how to find HCF and LCM. Okay, suppose 16, 24, 48. Suppose you decide, for example, all are divisible by 8, isn't it? All the three numbers. So you can divide by 8 directly. So 2, 3, 6. Okay, then now we can divide by 3. So 2, 1, 2. Now you divide by 2, 1, 1, 1. Okay. So can even you can follow this pattern. You can do this way also, or you can say they will divide by 4 here. Then you get 4, 6, 12, and divide by 2, 2, 3, 6. Now divide by 2, 1, 3, 2, sorry 3, then 3, 1, 1, 1. Okay. See, now we have divided different ways. So now HCF, how to find HCF? You take all the numbers by which, so all the three numbers got divided. See, for example, here in this case, if you look at it, okay, you divided all of them by 2. Here by 2 all got divided, yes. This also, yes. Okay, then here, no, here only 2 numbers, see 3 did not get divided by 2, isn't it? So you should not take this. Similarly here, so all got divided by this 2. Here no, 3, 8 did not get divided. Okay, now this one, yes. This one, yes. Okay. So here, yes, all three got divided by this, but not this one. So here all got divided by 4 and this 2 also. Okay. So now, so LCM, so here what, 2 into 2 into 2, so HCF you divide, you multiply all the numbers, so using which no, all three got divided. So here HCF is 2 into 2 into 2, so 8. Okay. So here also 2 into 2 into 2, you get see 8. So in this case just 8, yeah, here you get HCF 8, here 4 into 2, 8, understood? So for LCM, so you need to multiply, so all the factors, all these. Okay, so we know HCF already 8, so LCM will be, so multiply by the remaining factors. In the first case, so remaining 2 into 3. So 8 into 6, 48. Okay, LCM is 48. So here again 8, see 2 into 3, 6. So for 8 into 6, 48. Here also say 8 into 6, 48. Here also 8 into 6, 48. Okay, so this is how you get. Okay, but okay, see where we may go wrong if you okay, don't use prime factor when all the three are not getting divided. See, for example, here 16, 24, 48. You divide by, okay, let's say you want to divide by 12 now. So then you get 16, 2, 4. So now if you divide by 2, you get 8, 1, 2. And again you divide by 2, 4, 1, 1. Okay. So if you divide by 2 again, you get 2, 1, 1. Then we divide by 2, 1, 1, 1. Okay. So now this 12. So all three numbers were not divided by 12. So you should not take this. Suppose you use that rule now. So then now what? So this got divided, and this one, no, this is not. See, you're not getting proper value. You won't get. So you won't get HCF as 8 and LCM as 48 because see this one, this is wrong. So 12 you are divided by 12, which is not prime. Okay, only two of them got divided by 12, correct. So should not use this way. Okay, I want to okay, let's see more on this. I think you can have one more okay session on this vantage point in the next video. Okay, we'll see in the next video. Thank you.